let v bar equal to v1 of xyz I plus v2 of xyz j plus v3 of xyz k bar be the vector field or be the vector function having continuous first order derivatives, having continuous first order derivatives, in some domain containing D, containing D. Then now the statement double integral over S v bar dot n bar ds, double integral over S v bar dot n bar ds equal to triple integral over V. Let me change everything. First this one, let me take V, and here also V, just for simplification. Triple integral over V del dot v bar. Del dot v bar means divergence. Del dot v bar dv. Del dot v bar is known as divergence, or one can write in our another statement, in another way, double integral over S f bar dot n bar ds, because we define previous Stokes theorem in terms of f bar in place of v bar. Triple integral over V del dot f bar dv, del dot f bar dv. Here f bar is nothing but v bar. Okay, now using this statement, you have to remember this. Formula. What is this first thing? First one, let capital V, this capital V is the region bounded by the, and what is capital V? It is the closed region. Compulsory Gauss Divergence Theorem is applicable on closed region V, which is bounded by a surface S. Closed region V bounded by a surface S, and f bar is the vector function defined over V. Then double integral f bar dot n bar ds is equal to triple integral del dot f bar dv. Del dot f bar dv. Here n bar is the unit normal. N bar is the unit normal drawn outside to the surface S. Drawn outside to the surface S. This is as well. How to calculate n bar? You know, if surface equation is phi, then n bar equal to del phi by mod del phi. And another one, another form of Gauss divergence theorem. Another form of Gauss divergence theorem. What is the statement? Same statement. Everything is same, except what is the change here? If I will write in terms of f bar, f1 of xyz I plus f2 of xyz j plus f3 of xyz k is a vector function. Defined over the region R. Bounded by V. Take V. Defined over the region V, bounded over the closed region. Say closed region V bounded by the surface S. Then see another structure. What is this? We have then what we have, double integral over S f bar dot n bar ds is equal to triple integral over V divergence f bar, nothing but del dot f bar dv. del dot f bar dv, or the another structure is what? This double integral. Okay, double integral over yes f1. First one, f1 means, so f1 means what? Ith component. F1 means ith component. Then write its quotient as dy dz plus. F2 is jth component. Then write its quotient as dx dz plus. F3 is kth component. Write its quotient as dx dy. This is the theory. That means this del f bar dot n bar reduces to what? This structure, equal to there is no change on this one. One can write del dot f bar dv, del dot f bar dv, or one can write in this manner also, or I will remove this also, right? Double integral over yes f1. F1 stands for ith component. Ith component means x direction. Then right here dy dz plus. F2 means jth component, means in the direction of y. Then remove dy, write the remaining two derivatives. F3 jth component, kth component in the direction of j, z axis. Therefore write dx dy is equal to what is del dot f bar? You know what is del dot f bar? Triple integral over v, ith component derivative with respect to x, jth component derivative with respect to y, kth component derivative with respect to z, dx dy dz dv means. This is another structure of Gauss divergence theorem. So you remember this one, and this one. Problem will be given in any manner. Problem will be given in any manner. Okay. Now let me start the problem. First problem. First one. What? Verify divergence theorem. Verify divergence. Divergence theorem means what? It is obviously Gauss divergence theorem for f bar equal to x square minus yzi plus y square minus zxj z square minus xyk taken over the rectangular parallel piped bounded between 0 less than or equal to x less than or equal to a, 0 less than or equal to y less than or equal to b, 0 less than or equal to z less than or equal to c. Now, what is the question? Verify divergence theorem. For the vector function f bar is given, and what is this one? Over the rectangular box, nothing but parallelepiped means rectangular box. First, let me write Gauss divergence theorem. Gauss divergence theorem is, or states that, Gauss divergence theorem states that double integral over s f bar dot n bar ds is equal to what? Triple integral over v divergence f bar del dot f bar dv. Take this as equation 1. Verification means I have to find LHS value and RHS value, LHS integral, RHS integral, and both must give same answer. That is called verification. So let me take LHS first. LHS, what is this? Evaluation of, is voice is clear? Evaluation of double integral over s f bar dot n bar ds. Yes? Okay. Now, what is the rectangular box? See, this is very important. What is the rectangular box here? Let me draw. Okay, x-axis, y-axis, and z-axis. X-axis, y-axis, and z-axis. Let me draw the box. This done. Okay. Now draw this, and you can extend this. Join this. Join this. Join this. This is the rectangular box because every x value, y value, z value begin with origin 0. Done. Oh, let me take this point as B, okay, and this point as A. This corner points, I'm declaring only corner points A, B, C, and this one D, and this one E, and this one F. And let me take, okay, this is P. This P is the point, this is XYZ. P is the point XYZ. And along x-axis, what is the unit vector? I bar, this is K bar, and this is J bar. This is J bar. Now, what is the surface? Surface is the rectangular box. So, how to calculate, like in rectangle in 2 dimension, what we did in, for example, if a square is or rectangle is given, how we evaluate the line integral over C1, over C2, over C3, over C4. Join of C1, C2, C3, C4 is the curve C in line integrals, right? Now, in surface integral, surface S is the surface of this entire rectangular box, which consists how many subsurfaces? See, how many subsurfaces? This bottom one, this bottom. Okay, I will show here. This bottom, this is one surface. This is one surface. This is the bottom. Let this surface, I'm taking this one S1 surface, and exactly parallel to that top one S2 surface, and let me consider this surface, this side surface, this as S3 surface, and it's a parallel surface S4 surface, and one more important, front, that back one is there. What is the back one? Back surface, this one, this, and this back side. That surface I am taking S5, and front surface I am taking S6. It is not possible to show S6. Okay, let me write here S6, front one. Okay, all of you understood? 6 subsurfaces.
Yes, sir.
Yes. Okay. Right. Now let me write the surfaces here. The rectangular, the surface of rectangular box contains 6 subsurfaces. 6 subsurfaces given by, now one by one I will write. First one S1. What is that S1? See, S1 means this bottom. What is the bottom? O, A, E, F. O, A, F, E. O, A, F, E. Next one, S2. S2 means what? It's parallel top one. What is the top surface? I can write B, C, D, P. B, C, D, P. Okay, done. Next one, what is S3? Okay, I will write like this. What is S3 surface? Where S3 means this side one. What is this? This side YZ plane belongs to O, C, D, E. O, C, D, E. Next one. What is the S4 surface? S4 means it's a parallel surface, this one. That is A, B, P, F. A, B, P, F. Okay. Next one, S5 surface. S5 surface. What is the S5 surface? That back one. Back one means what? O, A, B, C. Back surface O, A, B, C. And last one is 6 surface, front one. Front one means what? This front part. P, D, E, F. P, D, E, F. Okay, P, D, E, F. These surfaces are there. Therefore, double integral over S, F bar dot N bar ds is now equal to double integral over S1, F bar dot N bar ds plus double integral over S2, F bar dot N bar ds plus, and so on. What is the last one? Over S6. f bar dot n bar ds. F bar dot n bar ds. Take this as equation 2. Now let me evaluate one by one. First, over S1. Over S1. What is S1 surface? Already told you, S1 surface is the bottom surface over S1. S1 is in what plane? See, what is the S1 surface? It is in XY plane, right? S1 surface is in XY plane. XY plane means what? Z equal to 0. XY plane means what? Z equal to 0. So I'm giving here just a small figure. This is S1 surface. I have taken, okay, this is first one, and this is another one, right? Like this I have considered. This is my S1 surface. This is X plane, X, Y and Z. This is S1 surface, and for this S1 surface, what is n bar here? Remember, n bar means it is the unit normal vector drawn outside to the surface. Drawn outside to the surface. Now, one important point. If for this surface, what is the actually unit normal vector here? Perpendicular unit normal vector means perpendicular. So what is that? K bar. But when I take K bar in this direction, Z axis direction, upward Z axis direction, but this unit normal vector is getting inside the surface. Inside the surface. K bar is inside the surface, not outside the surface. But when I consider this one, they like this. This is what? Opposite to K bar, therefore minus K bar. Then what is bottom? Bottom ki kindi nunchi ante surface lopaliki radadi. Bottom, if I draw normal vector to the bottom downwards, then minus K bar is the normal drawn outside to S1. This is the logic in this problem. I think got it. Therefore, what is n bar is here? I have to consider minus K bar. N bar is what? Minus K bar. Therefore, double integral over S1 f bar dot n bar ds. Now, what is this plane? XY plane. Remember, what is this plane? XY plane. So, double integral over S1. What is f bar? X square minus yz I plus y square minus zxj plus z square minus xyk. This one. Dot product with what? Minus K bar. Dot product with what? Minus K bar. And what is this? Okay, there is no place here. So let me write here. What is this? This is equal to double integral over S1. What is this? X square minus yzi plus y square minus zxj plus z square minus xyk bar. This one, dot product with minus K bar. And in XY plane, what is the projection? Dx dy by n bar dot K bar. N bar dot K bar. Okay, over XY plane, surface integral. So what is this becomes, and what is Z equal to 0 here? Here, Z equal to 0. So on XY plane, what is X is from, already it is given. What is the, this is A and this is B. It is given 0 less than X less than or equal to A, 0 less than Y less than or equal to B, 0 less than Z less than or equal to C. So in XY plane, X and Y varies from 0 to A, 0 to B, and put Z equal to 0 here. So X square, okay, let me take first dot product with the K bar only. So what I am getting? Z square minus XY, that's it. And with a minus sign. Okay, I will write this one clearly. This is minus K bar. So minus K bar means what this becomes? This becomes XY minus Z square, that's it. Dx dy by n bar dot K bar is what? 1 value. N bar dot K bar minus K bar dot K bar, this is 1. And what is Z value here? 0. So Z value 0 means what is this becomes? X equal to 0 to A y equal to 0 to b, just xy dx dy, because z equal to 0. So I can evaluate 0 to b, x square by 2. This is between 0 to a, y dy. So this is a square by 2 and this is y square by 2, 0 to b. So what is the value? A square b square by 4. This is the value over surface S1. Next, over S2. S2 means top one. What is the top one equation? See, I will show again. Just for two problems, I will draw the figure. Now this is S2. S2 means what? This is what? This is z-axis. If I take, this is x-axis, this is y-axis, this is A, and this is C. C means 0, 0, C. So what is this? This is S1. Parallel to this, at how much distance? C units distance. Equation of S2 is what? This is z equal to 0. XY plane equation, z equal to 0. So what is this equation? Z equal to C. Equation of S2 is z equal to C. Equation of S2 is z equal to C. Z equal to C means what is dz is not required. Z equal to C, then same, everything is same. Here z equal to 0 and one more point. And what is outward drawn? Normal vector means drawn outside. Now this is the top surface. This is the top surface. So obviously, what is the normal vector here? Not downwards, upwards. Here n bar equal to what? Positive k bar. N bar equal to positive k bar. Therefore, double integral over S2 f bar dot n bar ds is equal to, this is also above xy plane. This is what? Above xy plane. Belongs to xy plane but above. That is equal to double integral over S2. Now you write f bar dot n bar ds and dot with k, this one k bar. Dot product with here k bar only, plus k bar. Therefore, what I am getting? Z square minus xy only. Okay. You substitute everything. I am writing directly z square minus xy, and what is this? Dx dy by n bar dot k bar. So this is what? Same logic. There is no change here. Y equal to 0 to b. Previously z equal to 0 there. Now what is this z value? C. So c square minus xy dx dy. C square minus xy dx dy. That is equal to, now integration with respect to x, c square x minus x square by 2y. This is 0 to b. This is dy. This is between 0 to a. So this is 0 to b. C square a minus a square by 2y dy. That is equal to c square a y between 0 to b, a square by 2 y square by 2 between 0 to b. So answer is c square ab minus a square b square by 4. This is the value over S2. Now over S3. Over S3. What is the equation of S3? What I have taken S3? S3 means YZ plane. Okay. S3 means YZ plane I have taken. Now, what is S3? This is S3. This is Z and this is Y. Okay. This side one. This part. Done. And so what is the normal vector actually? This is I bar. And I have to take normal vector this side. This is positive I bar. Therefore, this is negative I bar. Negative I bar. Equation of S3 is, what is S3? YZ plane. What is that? YZ plane means x equal to 0. In brackets, you write YZ plane. YZ plane. And what is n bar? Drawn vector minus I bar. Therefore, double integral over S3 f bar dot n bar ds is equal to double integral over S3. Write f bar dot n bar minus I bar, and in YZ plane, what is this? dy dz by n bar dot I bar, yz plane, according to the formula. You write f bar here. So what is this? This is equal to, and y varies from 0 to b, z varies from 0 to c, and with respect to I minus I bar means this is first term you will get ith component y with minus sign, yz minus x square dy dz. And what is what is this plane? Yz plane. In yz plane x equal to 0, so this is z equal to 0 to c, y equal to 0 to b, just yz dy dz. Already same logic, so we are getting b square c square by 4 is the answer. Same. Now another over s4, over s4. What is the equation of s4? Equation of s4 is, this is what, this is y, and this is z, and this is x, this is a. Now actually what is this? S3, this is s3. S4 means this one, s4, this one s4. So what is the unit normal vector? Obviously outside to the surface, positive I bar, positive I bar. And what is the equation of s4? It is parallel to s3 at a distance of a units. Therefore equation of s3 is what? This is in yz plane, and parallel to yz plane means x equal to a, parallel to yz plane, parallel to yz plane at a distance of a units. And what is n bar here? Clearly I bar. Therefore double integral over s4 f bar dot n bar ds is equal to, I can write directly this one, yz plane 0 to b, z equal to 0 to c. And what is this one? Same with, here negative is there, now positive. This is x square minus yz. What is this? Dy dz by n bar dot I bar. So after this is equal to double integral, what is x value now? A square minus yz dy dz, a square minus yz dy dz. Same like this, positive. That means what you will get? A square, after evaluation what you will get? A square bc minus b square c square by 4 you will get. Similar evaluations. Next, over s5. What is s5? What is s5? Right, this is what is s5? This back one, back surface. This is belongs to which plane? Zx plane. This is belongs to which plane? Zx plane. This back one. Actually for this back surface, what is the perpendicular unit normal vector? This is y, j bar. But inside, this is inside, so I need a back side. అటువైపు నుంచి అటు వెళ్ళిపోవడం అంటే this is what? This unit vector is minus j bar, minus j bar. Equation of s5 is what? What is this? s5 belongs to zx plane. Zx plane means y equal to 0, so I will write zx plane. And what is n bar here? Minus j bar, minus j bar. Therefore double integral over s5 f bar dot n bar ds is equal to double integral. What is f bar dot n bar? Is j dot j means you will get zx multiplied by minus also, zx minus y square. Zx plane means dx dz by n bar dot j bar. So this is, and y equal to 0 here, so this part becomes 0. Zx, x is 0 to a, z is 0 to c, dx dz. So this value is a square c square by 4. And the last one, what is over s6? So s6 figure, this is front one. See, I'm showing this. This is the front one, s6. Okay, so I'm writing s6 here. And this is front one means what? Obviously this is minus j bar, this is y axis. plus j bar outside completely. Equation of S6 is what is this? This is parallel to, this is z and this is x, parallel to which plane? Zx plane. Equation of at a what distance? This is b. Okay, so this is what zx plane means y equal to b, parallel to zx plane, and what is n bar? Equal to j bar, positive z bar. Therefore double integral over s6 f bar dot n bar ds equal to double integral, what you will get now? Positive, no? So y square minus this one dx dz by n bar dot j bar, this is equal to, and what is y value here? Y value is b, so this is what we will get. This is b square minus zx dx dz, x is 0 to a, z is 0 to c. So after evaluation, what you will get? b square ac minus a square c square by 4. Now all the 6 subsurfaces over. Therefore equation 2 implies double integral over s f bar dot n bar ds equal to, what is the first one? What is the first surface? A square b square by 4. This is what? A square b square by 4. Second one is what? I think c square ab minus a square b square by 4. Second one is over. Plus next one is what? B square c square by 4 plus a square bc minus b square c square by 4, b square c square by 4 plus next one is what? What is this last one? A square c square by 4 plus b square ac minus a square c square by 4. Correct? Right. So these terms gets cancelled. So finally what I'm having? A square bc plus b square ac plus c square ab. ABC is common, a plus b plus c. This is the value of LHS. Now RHS. RHS is evaluation of, what is this? Triple integral del dot f bar dv. Okay, now triple integral over v del dot f bar dv is nothing but triple integral what? Dou f1 by dou x, dou f2 by dou y. You know divergence formula, components derivatives with respect to x, y, z, dx, dy, dz. So this is x equal to 0 to a, y equal to 0 to b, z equal to 0 to c. What is f1 derivative with respect to x? This is 2x and plus 2y plus 2z. This is dx, dy, dz. Since limits are constants, I can evaluate in any manner. So 2 is outside. Double integral x square by 2 plus y plus z into x. This is between 0 to a, dy, dz. That is equal to 2 into remaining limits you can write. Okay, this is a square by 2 plus a into y plus z, that dy dz. Correct? Now this is 2 with respect to, now let me take this is z equal to 0 to c. Y is, what are the constants? Az is also constant, so let me combine with this one. This is y plus a by 2 y square. This is between 0 to b. So what this gives? This is 2 into 0 to c, a square by 2 plus az into b plus a b square by 2. This is dz. Wow. Now with respect to z, 2 constants are what? Only this is z term, so I can take a square b by 2 plus ab square by 2 is the constant into z, ab z square by 2, this entire between 0 to c, entire between 0 to c. This is 2 into, this is a square b by 2 plus ab square by 2 into c plus abc square by 2. Okay, so 2 is LCM, gets cancelled, a square bc, a b square c, abc square. So abc is common, obviously. What is this? A plus b plus c. Okay, therefore LHS equal to RHS. Hence divergence theorem is verified. Hence divergence theorem is verified. Any doubts? This is the first problem only. Any doubts? Anyone respond?
No.
No, sir.
Is it clear?
Yes.
Yes, sir.
Yes, sir.
Okay. The next problem is verification. Why we need a verification? Okay. Next problem. Let D be the region bounded by the closed cylinder bounded by the closed cylinder x square plus y square equal to 16, z equal to 0 and z equal to 4. Verify divergence theorem. Verify divergence theorem if v bar equal to 3x square I 3x square I plus 6y square j plus zk plus zk. Solution. This is also verification. So what Gauss divergence theorem states that Gauss divergence theorem states that double integral over s. Now in place of f bar, v bar is given. That's it. ds equal to triple integral over v del dot v bar dv. Equation 1. Equation 1. Okay. Now let me evaluate RC. Always remember, the question may be let d be this surface will be given. Evaluate. The question is evaluate this integral. If the question is not verification, evaluate double integral over s b bar dot n bar ds. Actually, what is this? Surface integral. Now you can apply Gauss divergence theorem, convert surface integral to volume integral. Convert surface integral to volume integral. Gauss divergence theorem gives the relation between surface integral and volume integral. This is one way. Okay, one way of doing. If the question is evaluation of surface integral and the volume v is closed one, the domain is closed one, then you apply Gauss divergence theorem. Okay, so first let me evaluate RHS. RHS. What is that? Triple integral over v del dot v bar dv. Del dot v bar dv. Okay. Now what is actually surface? I'm giving the figure here. This is z axis, x axis and y axis. What is this? Cylinder x square plus y square equal to 16. This is the shape of the cylinder. Okay. Okay. Now, what is volume v is bounded by, and what is this is z equal to 0. z equal to 0 to what is given, z equal to 4. So this surface is z equal to 4. Okay, cylinder between z equal to 0 to z equal to 4. So not this bottom one. From here to it, this cylinder I have to consider. This cylinder I have to consider. Okay, not this bottom one. Okay. Now, what is the V is bounded by the cylinder x square plus y square equal to 16 between what? Between z equal to 0 to z equal to 4. Z equal to 0 to z equal to 4. Therefore, triple integral over V del dot f bar del dot v bar dv equal to triple integral over V dou by dou x of v1. What is v1? 3x square plus dou by dou y of what? Another one, 6y square dou by dou z of what? Z. This total dx, dy, dz. And remember, all of you, clearly z limits are given. Z varies from where to where? 0 to 4. And what is the remaining one? The circle. Okay, what is the remaining one? The circle. And what is this becomes? 6x plus 12y plus 1 dx, dy, dz. And over the circle, full circle, na, this one, what is this? The domain is now what? It is the full circle. It is the full circle. This is x square plus y square equal to 16. Okay, if I consider vertical strain, this vertical strain, what are the limits? Y limits negative root of 16 minus x square to positive root of 16 minus x square. And what are the x limits? This is minus 4 to plus 4. Minus 4 to plus 4. That's it. Okay, so now this entire, see, if I want to Jartha Vinandi step, the question is, if for example evaluate double integral over s v bar dot n bar ds, then convert this to triple integral. Convert this to triple integral. Otherwise, if you want to evaluate over surface s, the surface s is what? This one, and this curved one. Okay, so contains how many surfaces? S1, S2, S3. You have to evaluate surface integral over 3 subsurfaces. Anyway, its verification is there. Okay, but when the question is evaluate this one, if I convert to triple integral by using Gauss Divergence Theorem, that's it. This is evaluation. No need to evaluate over 3 subsurfaces. No need to evaluate over 3 subsurfaces. This much is enough. Triple integral. So, what is this one? Now, first one I can say this is z equal to 0 to 4. This is negative minus L to L. This is y. Y means odd function 0. Odd function 0. So what I can write, this is minus 4 to 4, y equal to 0 to root of 16 minus x square into 2. 6x plus 1 is the constant function. First dy, then dx, then dz. In brackets, minus L to L. What is this? 2ly dy equal to 0. Odd function. This is odd function. So remaining part integration. And multiplied by 2. 0 to 4. X equal to minus 4 to 4. And what is this? 6x plus 1 into y between 0 to 16 minus x square dx dz. That is equal to 2 into 0 to 4 minus 4 to 4. These are x limits. 6x plus 1 into root of 16 minus x square dx dz. Dx dz. Okay. Then what is the next one? I have to evaluate this, right? Now, minus 4 to 4, x limits. Now 2 into z equal to 0 to 4. I will write x equal to 0 to 4. See, only I think you will get this one, 16 minus x square dz. Why? Because integral minus L to L. What is this function? This one. 6x into 16 minus x square dx equal to 0, because what is this function? Odd function. X power 1 is there. X power 1, odd function. Okay, only this one. So what is this value? This is 4 into z equal to 0 to 4. What is this value? Integration x by 2. X by 2 into root of 16 minus x square plus a square by 2 into sine inverse of x by 4. This is between 0 to 4 dz. 0 to 4 dz. That is equal to 4 into 0 to 4. First upper limit 0. This is 8 into pi by 2 minus lower limit 0 plus 0 dz. So this is 4 pi. That means 16 pi 0 to 4 dz. That's it. Right. So 16 pi z between 0 to 4. 64 pi is the RHS value. Evaluation of volume integral. Now LHS. Evaluation of, see, if the question is evaluate this integral, then apply Gauss Divergence Theorem. Answer is this one. That's enough. But if you want to evaluate surface integral, evaluation of double integral over S f bar dot n bar ds. Now, what is the figure here? Y-axis, x-axis, and z-axis. How many surfaces? I told you this is z equal to 0, this is z equal to 4, and this curved one, this curved surface. What is that? X square plus y square equal to 16. This is what? S3 surface. S3 surface. Here, the surface S consists of 3 subsurfaces. 3 subsurfaces given by first one, yes. What is the equation? Z equal to 0, xy plane. Next, S2, Z equal to 4, parallel to xy plane. Parallel to xy plane. And S3, what is that? X square plus y square equal to 16, curved surface. Okay, now these 3. Now one by one I have to evaluate. Therefore, double integral over S v bar dot n bar ds is equal to over S1 plus over S2 plus over S3 over S3. Equation 2. First one over S1. I told you what is equation of S1 is xy plane, z equal to 0, xy plane, right? What is n bar? This is this one. Okay, now this is my, actually what is this one, sir? Always this is z axis, this is k bar is inside, this is S1, so minus k bar is outside, downward. So n bar equal to what? Minus k bar. N bar equal to what? Minus k bar. Therefore, v bar dot n bar ds equal to, what is v bar? V bar dot n bar. So v bar dot minus k bar. This is dx dy by xy plane now, n bar dot k bar. So what is v bar dot minus k bar value? Minus z you will get. Minus z dx dy by, this is 1. I'm not writing the limits. Why? Because this is 0. Since equation of S1 is z equal to 0. First one is over. Next one. Over S2. equation of S2 is what? Z equal to 4. And what is n bar above? Above means what? Positive k bar. N bar equal to positive k bar. This is over S1. S2 v bar dot n bar ds equal to double integral v bar dot k bar dx dy by n bar dot k bar mod. This is the formula of surface integral. That is equal to, what is this, becomes z dx dy. What is z value? 4. So 4 double integral over what? S2 double integral over S2 dx dy. Double integral over S2 dx dy. So what is this answer now? What is S2? S2 means what? This one. This is S2. What is this? Is equation z equal to 4. Nothing but a circle. This is, you write, what is this? 4 into double integral dx dy means what? Area. Area of S2 bounded by, what is that? Circle. Bounded by the circle x square plus y square equal to 16 with radius 4. With radius 4. Therefore, this is 4 into, what is this? Pi r square. So 4 into pi into 4 square. 64 pi is the value over S2. Now lastly S3 over S3. Equation of S3 is, what is that? X square plus y square equal to 16. This is phi. Therefore, what is n bar? Del phi by mod del phi. What is del phi? 2 dimension. I into dou phi by dou x, j into dou phi by dou y plus 0 by, what you will get? 4x square plus 4y square. So what is n bar? Equal to 2 gets cancelled. You will get x sine plus yj by x square plus y square. 16 means 4. Since x square plus y square equal to 16, you write. Done. Okay. Therefore, double integral over S3 v bar dot n bar ds equal to double integral v bar. What is, now I have to write v bar. 3x square I plus 6y square j plus zk dot x I plus yj by 4. And what is this? Dx dy by n bar dot, if you want to write n bar dot k bar, it's not possible, right? Because there is no k bar here. Denominator will be 0. Denominator will be 0. So let me keep ds as it is. This ds as it is. Now this is over S3. See this problem. If I take n bar dot k bar on xy plane, okay, this is not on xy plane. And one more important point. What is S3 here? S3 is here. What is S3? This is S3. S3 is not in xy plane. Okay, remember it varies from z equal 0 to z equal to 4. Now what is this? Double integral S3 1 by 4 outside 3x cube plus 6y cube. I will write ds. Here S3 over S3. Here over S3, z varies from z equal to 0 to z equal to 4. Z varies from z equal to 0 to z equal to 4. Therefore, using, now I have to evaluate this integral. I have to evaluate this. What is ds becomes? I have to evaluate ds using cylindrical coordinates. Using cylindrical coordinates, we write x equal to this one. What is this? See, what is S3 actually? X square plus y square equal to 16, and z varies from 0 to 4 over S3. So first parametric, nothing but parametric expressions. This is 4 cosine theta y equal to 4 sine theta. And one more important point is here, this is over S3 now. Over S3, what is this ds becomes over S3, over S3, ds is equal to, actually in xy plane, what is this becomes dx dy, dx dy. But here z is varying, always z is varying. Therefore, there must be dz. There must be dz. And another variable is what here? I'm converting into polar. So d theta. Another one is d theta. Next, another one is what? Do you remember? In polar coordinates, what we have? Dx dy. ds is nothing but dx dy equal to r dr d theta. Do you remember? ds equal to dr dx dy. In polar coordinates, what is this becomes? R dr d theta. And this is, I will write r. R. And what is r here? Here, r is equal to z. Theta is theta. This is just idea. So this is what is r value? 4 d theta dz. Once again, I am repeating to evaluate this integral where z is varying over S3. So one of the variable must be dz. It's z. So I'm taking parametric equations for this circle 4 cos theta, y equal to 4 sin theta. So one of the variable is theta here, and another variable is what? Z, because it is varying over S3. It is varying over S3. Therefore, what is ds? ds is nothing but in general, just this is idea only, dx dy. In polar coordinates, what is dx dy? R dr d theta. So r is as well. R is as well. R means radius. D theta is as usual, and dr. What is the radius line here? Z. Z varying from 0 to 4. So dz will be there. Hence, what is the finally? Therefore, double integral over S3 v bar dot n bar. V bar dot n bar ds equal to, what is the final one? What I have got? 3x cube. Double integral 3x cube 4 cos theta cube plus 6y cube 4 sin theta cube. This total cube. What is this? 4 d theta dz. And theta varies from circle 0 to 2 pi. 0 to 2 pi. So what is this? This equal to 3 now only, 3 and 6. 6 correct, I have written correct. So this is equal to, first theta equal to 0 to 2 pi, 1 by 4, right? And z equal to 0 to 4. And what is this becomes? 12. 12 3 is a, sorry, 16. 64 into 3. 64 into 3, 192 cos cube theta plus 64 into 6. 64 into 6, 384. 384 sin cube theta. Sin cube theta. This is 4 d theta dz. This 4 gets cancelled now. Okay. Now express everything in terms of 3 thetas. Theta equal to 0 to 2 pi. This is z value. Cos cube theta in terms of 3 theta. What is this? Becomes cos 3 theta plus 3 cos theta. Is it correct? What is cos 3 theta? Formula 4 cos cube theta minus 3 cos theta. So 4 cos cube theta plus by 4 will be there. Correct? Plus 384. What is this? 3 sin theta you will get minus sin 3 theta by 4 will be there. This is 192 d theta dz. This whole bracket. And one more, see, right. Say cosine integration is what? Sine. This is sine between 0 to 2 pi. What is the value? 0. And this is cosine. Sine integration cosine. And here also cosine 3 theta you will get minus. and this is between minus, if I take outside, between 0 to 2 pi, and this is between 0 to 2 pi. What is this? Positive only now. So this also 0. So entire will 0. Okay, therefore equation 2 implies double integral over s v bar dot n bar ds equal to over the first integral 0, over the second integral 64 pi, third integral 0. So answer is 64 pi. Therefore LHS equal to RHS. Therefore divergence theorem verified. Divergence theorem verified. Okay, this is one problem, and let me take another one. Use divergence theorem. Use divergence theorem to evaluate double integral over s v bar dot n bar ds, where v bar equal to x square z I plus yj minus xz square k, and s is the boundary of the region bounded by the paraboloid z equal to x square plus y square, and the plane z equal to 4y, and the plane z equal to 4y. Now see, this is not verification. What? Apply divergence theorem to evaluate the surface integral. Done? Okay. By divergence theorem, we have double integral over s v bar dot n bar ds is equal to, what is that? Triple integral over v del dot v bar dv. Del dot v bar dv. Okay. Then what is this? Del dot v bar means what? This is here del. Okay, let me write directly. This is equal to triple integral del dot v bar, dou by dou x of v bar lo first ith component plus dou by dou y of jth component plus dou by dou z of minus xz square. This is dv. So triple integral over v, this is 2xz plus 1 minus 2xz. dv means what? Dx, dy, dz. Okay. Oh, these two are getting cancelled now. So what is this? A simple. This is equal to triple integral over v dx, dy, dz. Volume. Volume of what? Here, where v is the volume bounded by the paraboloid, what is that? Z equal to x square plus y square, and the plane, what is the plane? Z equal to 4y. So I have to find the limits for this. Just I am giving a rough figure, not exact figure. If I take this as y axis, not x, this is x and this is z. Put z equal to 0. Therefore x square plus y square equals 0. Done? Next one. Put z equal to 1. X square plus y square equal to 1. Circle. Z equal to 2. Another one. Z equal to like this. So this is like this. Okay. And z equal to 4y. Same logic. If I put z equal to 0, y equal to 0. Z equal to 1, what is y value? Z equal to 1, y value 1 by 4. And here z equal to 1, x square plus y square equal to 1 here, and 1 by 4. And the simple logic I had to how to tell. Yeah, forget about the figure. I will tell the logic. Figure is like this only, but I will tell the logic. See, When x equal to 0, y equal to 0, what is z value? 0 here. From this z value 0, from this z value 0. When x equal to 1, y equal to 1, from this what is z value? 1. From this what is z value? When x equal to 1, z value 4.
So let's say z equal to 2.
Is it clear now? Screen?
Screen is not visible, sir.
Hello? Screen is visible.
Screen is not visible.
Screen is not visible, sir.
Now? Is it okay?
Yes, sir.
Okay. Now, now, is it clear? See how to decide the limits from the paraboloid at x equals 0, y equals 0, z equal to 0. And here also z equal to 0. To decide the upper limit, when x equal to y equal to 1, z value is 1 here. When x equal to y equal to 1, z value is what?
So left side z equal to 2.
Z equal to 2. Where?
When x equal to 1, y equal to 1, 1 square plus 1 square, 2.
2. Here at x equal to 1, y equal to 1, z equal to 4, right? Okay. So, which one is the upper one? Z equal to 4 is the upper one, right? So, z equal to 4y will be the upper limit and z equal to x square plus y square will be the lower limit. Therefore, this is equal to, first let me write z limits. Z equal to x square plus lower limit lies on the paraboloid and upper limit lies on the plane. Upper limit lies on the plane. What is this becomes? What is this integrand? Just dz dx dy. I will write limits of x and y later on. So what is this equal to? Double integral z between x square plus y square to 4y dx dy. Double integral, this is 4y minus x square minus y square dx dy. Okay, here this is, let me take r. R is the region, this is r I will take. R is the region bounded by what? Bounded by, see, what is the paraboloid equation? X square plus y square equal to z. Z in terms of y is given 4y, bounded by the circle. Bounded by the circle, x square plus y square equal to 4y. In bracket, since z equal to 4y. This is in xy plane. So what is the circle? If I take this as y-axis, this as x-axis, this is circle lies on y-axis. Center lies on y-axis. This is x square plus y. Okay, y I will confuse you. Let me take directly. This is x-axis and this is y-axis. And what is the circle? Center lies on y-axis. This is the center. So this is x square plus y square equal to 4y. Okay. So what are the limits? What are the limits? If I consider horizontal strip, x limits are negative 4y minus y square to positive 4y minus y square. And the y limits are what? This is 0 and this is what? This is what limit? On y-axis x equal to 0. So y gets cancelled, 4 you will get here. 4, y equal to 0 to 4. 4y minus x square with respect to x now first. So let me write like this. 4y minus y square minus x square dx dy. Dx dy. You evaluate this and I am giving answer directly. Whatever the techniques you apply, the answer is 8 pi. Answer is 8 pi. And next one. Gauss Divergence Theorem. Yeah, this problem is over. I have to tell one problem based on. See the solved problems in Gauss textbooks. You solve them. Gauss textbook problems, you solve them. Now I'm telling exercise problems using divergence theorem. Using divergence theorem, prove that integral over s r bar dot ds bar equal to 3v del r square dot ds bar equal to 6v, where s is any closed surface enclosing a volume v, and r square equal to x square plus y square plus z square. Solution. What is this? Using divergence theorem, we have this is integral over s r bar dot ds bar. Integral over s is nothing, over s means it is nothing but surface integral. R bar dot ds bar is nothing but n bar ds. Ds bar is nothing but n bar ds. So using Gauss divergence theorem, what is this is in place of f bar, here f bar is what? R bar. That's it. So triple integral over v del dot f bar dv. What is divergence r bar? You know, divergence r bar value 3, right? So 3 triple integral over v dv, nothing but this is 3v. This is equal to 3v, where v is the volume. Where is the volume given? That is bounded by closed surface. V is the volume bounded by closed surface. Yes, closed surface. Yes, that's it. 3v is the first answer. Next, what is the second one? Second question, del r square integral over s del r square dot ds bar. This is double integral over s del r square dot n bar ds. Ds bar is nothing but n bar ds. So using divergence theorem, what is here? What is f bar? F bar is del r square. Okay, so this is del dot f bar del r square dv. Del r square dv. What is this becomes? Del is nothing but del square r square. Do you remember? Del phi is del square phi. This is the formula. Okay, what is del square r square means? What already I have given. This is over v dou square by dou x square of x square plus dou square by dou y square of y square, dou square by dou z square of z square. In r square, these derivatives. So this is triple integral. This is 2, this is 2, this is 2 dv. Nothing but 6 triple integral dv equivalents to what? 6v. Equivalents to what? 6v. Now another one. If s is any closed surface enclosing a volume v and f bar equal to axi plus byj plus czk, prove that integral over s f bar dot n bar ds is equal to a plus b plus c into b. Just I am giving hint only for this problem. Hint. You have to solve this. Integral over s f bar dot n bar ds is equal to double integral. Integral over s means what? Double integral. This is equal to, using divergence theorem, what is this? Del dot f bar dv. That's it. So triple integral del dot f bar means what? Dou by dou x of ith component, dou by dou y of jth component, dou by dou z of kth component. That's it. This is dv. Finished. This is over V. This is triple integral over V. What is this? A plus B plus C dV. That is exactly A plus B plus C into triple integral dV. Nothing but V. Volume. Next problem. I have to tell in XYZ. Yeah, this problem. I will tell one problem. This is V. See, remember this problem. Sphere problem is again. That's better. See, evaluate double integral over S x dy dz plus y dz dx plus z dx dy z dx dy over a surface of a sphere over a surface of a sphere over a surface of a sphere of radius a solution. Now observe this integral. Is it a direct form? Double integral over s f bar dot n bar ds? No. This is another form of Gauss Divergence Theorem. Using, I will write another form of divergence theorem. We have, what is that another form? Double integral over s f1. F1 stands for ith component, means x direction. So write here dy dz plus f2 jth component y direction, then write xz. Similarly f3 dx dy is equal to what? This is also equal to what? Triple integral over v del dot f bar dv equal to del dot f bar dv. Okay, so according to that, here what is f1? F1 stands for coefficient of dy dz, that is x. F1 is x, f2 is y, f3 is z. Therefore double integral over x dy dz plus y dx dz plus z dx dz, this is the given one, equal to what? Triple integral over v del dot f bar dv, that is equal to triple integral over v del dot f bar means dou f1 by dou x, dou f2 by dou y, dou f3 by dou z dv. Now you know what is f1, what is f1, f2, f3, that is equal to triple integral, this is 1, this is 1, this is 1 dv over v. So 3 into triple integral over v dv. What is that? Nothing but triple integral over v dv means volume of the sphere, volume of the sphere with radius a, with radius a. What is answer? Volume of the sphere is what? Hello?
4 by 3 pi r square.
Volume of the sphere. Huh?
4 by
Hello?
4 by 3 pi a cube.
Pi r cube. Okay, done. So 4 pi a cube is the answer. One more problem. Oh, just wait. Hmm. 19 pages are over. Okay. Now, let me take another problem. by transforming to triple integral, by transforming to triple integral, evaluate double integral over s x cube dy dz plus x square y dz dx x square z dx dy, where S is the closed surface, S is the closed surface consisting of the cylinder, x square plus y square equal to a square, and the circular disc z equal to 0 and z equal to 4. This is solution. Same double integral over s. Okay, directly I will write because I already explained what is f1 here. Here f1 dy dz quotient x cube, f2 x square y, f3. Always remember, don't write directly f1 f2 f3. See the quotient. Dy dz quotient is f1, dz dx quotient is xz, means y means jth component, that is f2, like that. Okay, by Gauss divergence theorem, what is this double integral over s f1. Okay, I will write directly. What is that? Question is x cube dy dz plus x square y dx dz plus x square z dx dy is equal to triple integral over v del dot f bar dv. That is equal to triple integral over v dou by dou x of f1 plus dou by dou y of f2 plus dou f3 by dou z dx dy dz, or dv you can write, no problem. This is equal to triple integral over v dou by dou x of f1. F1 means what? Derivative 3x square, and dou by dou y means this is x square, dou by dou z means this is x square, this is dx dy dz. That is equal to triple integral how much? 3 plus 1 5 x square dx dy dz over v. And what is volume v? Already I told, we did this problem. It is bounded by z equal to 0, z equal to b, done. And this circular, what is this? X square plus y square equal to a square is given. Okay, so z limits are fixed first, done. So 5 z limits are fixed 0 to b, and remaining is the circle. So I can write y equal to minus root of a square minus x square to plus root of a square minus x square, and x equal to minus a to plus a, done. And better my idea is, instead of doing like this, first let us eliminate z. What is this? This is 5. I will take r, z equal to 0 to b, x square dz, next dx dy. That is 5. I can write directly, this is double integral over s x square z between 0 to b dx dy. That is equal to 5b double integral x square dx dy over r. What is r? R is the region bounded by circle. The circle. X square plus y square equal to a square. That's it. You know the circle, and you consider vertical strip, whatever it is, 5 into, if I consider vertical strip, y equal to minus a square minus x square to plus a square minus x square, x equal to minus a to a, x square first dy then dx. So 5, this is even function. Okay, I will write here. This is 5, x equal to minus a to plus a, even function. Okay, this is 2 into, I will write directly x square y between 0 to a square minus x square. So this is 10 into minus a to plus a, x square into root of a square minus x square dx. Then this is completely even function. Even function means 20 to 0 to a, x square into a square minus x square dx. You can evaluate. Put x equal to, just 1 minute. Put x equal to a sine theta. Then dx equal to a cos theta d theta. And theta varies from 0 to 2 pi. This is equal to 20. Theta equal to 0 to 2 pi. X square, a square sine square. This is a square, a outside. A square, this is cos theta. Dx is a cos theta d theta. Okay. You evaluate this. Answer. Okay. This is Gauss Divergence Theorem topic. Gauss Divergence Theorem topic. And one more, fastly, one small topic is there. What is that? Irrotational fields. Irrotational fields. A vector field definition. A vector field or a vector function f bar is called, you know, already I told you, irrotational if del cross curl f bar equal to 0. If curl f bar equal to 0. Okay, this is the definition. We know that del cross del phi is what? 0. We know that del cross del phi is 0. Therefore, whenever del cross f bar equal to 0, we can find a scalar function phi, such that see, observe, del cross del phi 0, del cross f bar 0. So I can take f bar as, I can find a scalar function phi such that f bar equal to del phi. F bar equal to del phi, such that f bar equal to del phi, where phi is called scalar potential function. Phi is called scalar potential function. This is important. Definition is very important. Phi is called scalar potential function. And one more point. What is the purpose of this scalar potential function? You write like this. What is the work done formula? Work done is from A to B, f bar dot dr bar. Work done in irrotational fields. Irrotational field becomes okay, f bar dot dr bar is nothing but, irrotational field means what? Curl f bar equal to 0. When curl f bar equal to 0, but then I can write f bar equal to del phi dot dr bar. What is del phi dot dr bar now? Del phi means what? I dou phi by dou x, j dou phi by dou y, plus k dou phi by dou z, dot dxi dyj plus dzk. What is this becomes? Dou phi by dou x dx, dou phi by dou y dy, dou phi by dou z dz. Right? This is from A to B. Now this is total differential. What is the total differential? This is equal to A to B d phi. A to B d phi. Nothing but phi. Phi is nothing but function of x, y, z between what points? A to B. So 5 at B minus 5 at A. This is the work done formula. Work done formula in irrotational vector fields. So depends on what? Work done is depends on endpoints. Depends on endpoints. Okay, this is one observation. And let us solve one problem based on this. Yeah, fine. And one more important point, note. Therefore, if f bar is irrotational, then the work done is independent of the path joining the points A and B, independent of the point join A and B, and depends only on endpoints, endpoints of the evaluated at scalar potential function. This is important. If the question is independent of path joining A and B, means you have to find first find f bar is irrotational or not. If f bar is irrotational, the work done means line integral is independent of the path. Now, based on this note, one example, find whether integral over C 2xyz square dx plus x square z square z cos yz dy, sorry, dx z cos x square z cos yz dy, this bracket, plus 2x square yz plus y cos yz dz, this whole bracket close, is independent of the path joining 0, pi by 2, 1 and 1, 0, 1. If so, evaluate this line integral. First solution, we have to find independent of this one. So first observe what is f bar. Here, what is f bar? You know, this integral is given as f bar dot dr bar. This entire is, so what is f bar? 2xy z square I plus x square z square plus z cos yz j plus what is that, another one, 2x square yz plus y cos yz j k. This is f bar. Now find a curl f bar. What is that? Curl f bar I j k dou by dou x, dou by dou y, dou by dou z 2xy z square x square z square plus z cos yz 2x square yz plus y cos yz. You have to find this. Definitely you will get 0 answer. Okay, since del cross f bar is 0, f bar is irrotational field. F bar is irrotational field. Hence, integral over C F bar dot dr bar, this is the given integral, is independent of the path, joining the points A and B, okay. Hence evaluate it. Question is what? Hence evaluate it. Okay. Now this is the main thing. Listen carefully. Since del cross F bar equal to 0, we have F bar equal to what? Del phi. We have F bar equal to del phi. This implies, what is F bar? Let me write. జాగ్రత్త వినండి ఇక్కడ నుంచి 2x y z square I plus x square z square plus z cos yz j plus 2x square yz plus y cos yz k. This is F bar. I will write here. F bar equal to del phi implies equal to del phi. What is del phi? I dou phi by dou x, j dou phi by dou y, plus k dou phi by dou z. Okay, I'm taking this equation, substituting in this one. Therefore, what I'm getting, first ith components are equal. So 2xy z square. Next, 2 dou phi by dou x is over. Now dou phi by dou y is what? X square z square z cos yz. Dou phi by dou z, 2x square yz plus y cosine yz, clear? Ith component, jth component, and kth component. Take this as 1, this as 2, this as 3. I need what? Just I'm giving, we need phi. Uniquely. We need phi uniquely. This is important. Okay. So taking, see, integrating, this is dou phi by dou x. So to get phi, integrate 1 with respect to x, treating yz as constants. Yz as constants. Then 1 implies this becomes what? Phi x yz. Dou phi by dou x integration becomes phi, and with respect to x means what? X square y z square, x square by 2, plus I have to write constant. I will write this constant as something. What is that something? I will write this is function of, since yz are constants, I will take this as function of yz. Same logic. Integrating 2 with respect to y, treating xz as constants. Then 2 implies this is also phi of xyz, and treating yz as constants means this is what you will get, x square y z square you will get. And in the second one, integration with respect to y, z is constant. This is sine yz by what? Yz low a the constant, z constant. So you will get z plus what is the constant? Xz, function of x with z, which is taken as a constant. So z gets cancelled. So from this, what I'm getting? X square y z square plus sine yz plus f2 of xz. This is equation 5. I think clear it is. Now third one, integrating equation 3 with respect to z, treating x y as constants. Then 3 implies, so this is also phi x y z equal to, what is this third one? Dou phi by dou z integration with respect to z means this z phi integrating with respect to z x y z square you will get here first term x y z square you will get not x square is there x square y z square and next one this is with respect to z so by y sine yz y sine yz by y plus constants are what these two so this implies what is phi of xyz x square yz square plus sine yz plus f3 of xy this is equation 6 now what is the motto to get unique scalar unique scalar potential function phi choose I will write see what first one what is that fourth equation phi of xyz equal to what is the fourth equation x square yz square x square yz square plus function of yz equation 5 implies phi of xyz equal to what is the phi phi is x square was sine yz x square yz square sine yz plus in the second one what are the constants xz and sixth one phi xyz is equal to x square yz square plus sine yz is there and what is the constant xy now what is the motto to get unique scalar potential function phi choose now see choose f1 of yz function of yz as sine yz because here sine yz is not there here sine yz is there and f2 of what is another one xz constant some c and f3 of xy you take constant c so how to choose this the idea is I'm giving take union of all the three expressions take the union of all the three expressions you know in set theory union means what a union b write all the elements without repetition this is very important without repetition then what is unique find see you write all the terms in the first one second one third one this term is there and what is another different term sine yz and you put c because I have taken c here this is the potential function any doubts you can raise just combine all the three equations without any repeated term different terms union all the different terms union that gives potential function then what is this integral f bar dot dr bar over c is what I have already taken proof phi at b minus phi at a okay that is equal to what see what is the given hence evaluate the integral is given what is phi x square y z square plus sine yz plus c at what point b point is what 101 minus x square yz square plus sine yz plus c at what is the a point 0 comma pi by 2 comma 1 0 comma pi by 2 comma 1 so what is this implies now this is y is 0 so this part 0 plus c will be there minus here x is 0 so 0 plus sine yz sine pi by 2 1 will be there done plus c is there so minus 1 is the answer any doubts Any doubts? Next problem. Just I will explain one more. A fluid motion is given by v bar equal to y plus z I z plus x j x plus y k. Question 1. Is this motion irrotational? Second question. If so, find velocity potential. If so, find velocity potential. Third one. Is the motion possible? Is the motion possible for an incompressible fluid? For an incompressible fluid. Solution. First, v bar y plus z I z plus x j x plus y k. First one is motion is irrotational. So find del cross f bar. I j k dou by dou x dou by dou y dou by dou z y plus z z plus x x plus y. Okay, you calculate this, definitely you will get 0. Therefore, f bar is irrotational. F bar is irrotational. And B, since del cross f bar equal to 0, we can find potential function phi such that f bar equal to what? Del phi. F bar equal to del phi. Here in fluids phi is called velocity potential function. Okay, now I have to calculate this phi as usual, like a previous method. F bar equal del phi. What is f bar? You write y plus z I z plus x j plus x plus y k equal to I dou phi by dou x j dou phi by dou y plus k dou phi by dou z. So equate ith component, jth component, so on. Then dou phi by dou x is what? Y plus z, equation 1. Dou phi by dou y is what? Okay, I will write clearly. This implies dou phi by dou y is what? Z plus x implies. Dou phi by dou z is what? X plus y implies. From this integrating, what I am getting? Integrating with respect to x, xy plus xz plus treat yz as constants. Integration with respect to x. Okay, simply you write integrating with respect to x. Here integrating with respect to y. Then what I am getting here? Xyz equal to yz plus xy. What are the constants here? Y means x and z are constants. Same logic, integrating with respect to z, phi xyz equal to xz plus yz. And what is the what are the constants? This. To get unique phi, choose. Now I will write directly. What is unique phi? I told you already, union of all these three. What is the first different terms? One is xy, another one is yz, another one is zx. Any more different term is there? No. Choose, and plus c you can write. Plus c. Choose f1 of yz equal to, see, yz. Here xy is there, xz is there. yz is not there. So choose F1, this yz plus c. Similarly, F2 of xz, second one, xz, yz is there, xy is there, zx is not there. So I'm taking zx here. And F3, xy. In the third one, xy is not there. So I will choose this one. Then phi of xyz is the potential function. Is the potential function. Clear? And one more point. What is the third question? Fluid motion is possible. Fluid motion is possible for an incompressible fluid. Incompressible fluid if it satisfies the equation of motion. If it satisfies the equation of motion, that is, what is the equation of motion? Divergence v bar equal to 0. Equation of motion is divergence v bar equal to 0. So what is this v bar? This x plus z, no, y plus z, dou by dou y of now del dot v bar. Del dot v bar equal to dou by dou y of x plus z, dou by dou z of x plus y. What is this? 0 plus 0 plus 0. That is 0. Hence, motion is possible. Hence, fluid motion is possible. Fluid motion is possible. Okay, this is the another problem. And I will give assignment for you. First one. Okay, I will post the assignment in another PDF. Just you write down because I have to go to college now. Any doubts in this topic? With this, your first semester syllabus is finished. Any doubts?